So I'm going to walk you through how to set up these problems. If you feel like you can set them up yourself, then you can just skip this part, I guess. All of these are fairly simple chi-squares. So let's start with this one because this is where we're going to be going. You'll watch a video of pill bugs in a choice chamber, and you'll collect data every 30 seconds for their location. So studying animal behavior, that's the name of the lab. Because they're animals, it seems crazy, but they are. They're also isopods. That means same feet. So they have the same style of feet, and so that's part of what they're classified as. And we're looking at distribution in a choice chamber, and we're going to test for preference. So you're seeing if there's a preference between any of the areas in the choice chamber. And what that means is, if you think about it, it would mean not all conditions are the same if there's a preference. So you're going to put a cotton ball on one side and you're going to have water on it. And then you're going to have a cotton ball on the other side without water. And it says here that it's a two-choice chamber. All right, so it's going to look, let me move this over here. And there's how many? 15 minutes, 2 are located in chamber B, which is the dry, and 18 in A. All right, so this is how we would set this up. So for the first one, just to give you a little visual, you're going to have a choice chamber that looks like this. They don't really make those, but that's what it is. So this is A, this is B. They both have a cotton ball, except this one is wet. So I'll make it kind of look like cotton. And this one's dry. And we drop them in there. You drop 20. So the way you set up the chi-square is for the categories, it's what different conditions did you observe. This would be the condition of the wet side, the condition of the dry side, so you only have 2. You're going to always be given this particular box, but we're going to draw it in here for now. And it starts off with, what did you observe? You always want to think about this as what did I count? So you count numbers and you observe. And then here, this is your observed conditions. And that becomes your categories. So they said on the wet side that they had 18, and on the dry side, they had 2. And being a simple chi-square, we're going to always test for the null is that there's no difference between these two conditions. So let's write the null. So there's the hypothesis, that's null, and you're going to write the same beginning every time. You're going to state there is no significant, and that's an important word, difference. And then you're going to state between the conditions. So there's no significant difference in this is what did you count? And this is your categories. So I would fill this in as that there's no significant difference in I counted pill bugs, so it's the number of pill bugs. In what are your 2 categories? The wet and the dry. Wet and dry chambers. So that null works every time. And so you're testing that there's no difference. If it fails, which means you have a big chi-square, which I'm thinking this one will, then there is a significant difference. Now, significance is really important. You cannot use this word just to say hey, that's an important whatever or significant. I think it was something I would take note of. It's not that. In this statement, it means I did stats. I can give you chi-square value. I can give you some statistical analysis. Don't throw it around unless you've done some math. So you could set this up. Let's think about our expected. If there's no difference between the two chambers, and I had 20 total pill bugs, then I would expect that there would have been 10 and 10 in each one. So you can do the math. When we come back, I'll show you all of mine, but we're going to set up another problem. So let's go to the next one. So problem 2. Where'd it go? All right. Again, we're going to roll a die. So it is a die. The roller has 6 possible outcomes. Emily is like all about rolling the number 5. She thinks she's supernaturally able to roll 5s. She rolls the die 300 times, and this is what she records as an outcome. So we put, the way our tables are set up, we put the different categories or the conditions that you would find this. So you would have the condition of rolling a 1 or a 2 or a 3. So we would set it up this way. You would have 1, 2, 3, 4, 5, 6. And so this would be, hey, I'm doing pretty good with my lines. So this is your categories. These are the observed conditions. Whoa, look at me. I haven't gone to it. There. Wow, that probably makes more sense. So these are your observed conditions, the condition of rolling a 1, 2, 3, 4, 5. Then you're going to have what you observed, which would be the number of times that you did that. So let me go back over here and bring this up again, and I'll put those in. So it's 15, 70, 33, 31, 89, and 62. Now, I'll be real truthful. If I write these, they're not as nice. And this is what I mean. Notice how that they rolled this 300 times. Oh, isn't that sweet? Because 6 goes evenly into 300. So you're not going to have some crazy number over here with decimals for expected. I'd have said 100. Just because you'd have had something that would have left you with decimals. That's just me. So for expected, if your total is 300 and all of these different observable events have the same likelihood, you take 300, you divide it by 6, and you should have had the same exact ones as far as number of times that you saw 1s or 2s or 3s. So let's write the null again. So instead of writing this part, that gets old. It never changes. There is no significant difference. So we put there is no significant difference. And you can do that anytime you're doing something for me, but in May on the real test, write it out. In what did I count? I counted the number of rolls, right? The number of times that we got this, and what categories. The categories are the numbers on the die. So there's no significant difference in the number of times. And then the categories are that the die, I guess, really lands on any of the 6 sides, because that's what we're talking about. They're the sides. So you're going to test that there's no difference. If your chi-square values are small, which means you have small differences, it also means that if you're small, you're going to have a chi-square that's lower than the cutoff, which is the critical value. And at that point, you're going to accept that there is no difference. So you accept the null. If instead you get a big old chi-square, which is an indicator of there's big differences between what you saw and what you expected, your chi-square value would be larger than your critical value, and you would say these differences are too large to be due to chance, so there is a significant difference. So you would reject the null. Now, the math teacher in me can't stand that because you really failed to accept, but in biology teacher, we just say reject. So this is just a heads up on whether you accept or reject the null. Okay, so let's set the next one up. Back to pill bugs again. They're going to use a choice chamber. This time they're going to use the two-sided one that has the middle spot, and you're going to put ripe grapes on part A. So I'm going to draw this while I'm talking, and then you can see it when you come back. So these are ripe grapes in A, and then it says not ripe grapes in B. In the choice chamber, it says has a large enough middle passage where the flies can remain. So after 40 minutes, you have 20 in the middle, and you have 43 in A and 36 in B. Okay, so let me show you what I drew. So this is that type of choice chamber. Mine's smidgen exaggerated there with the middle. So this is the middle. And these were what that they observed. They observed that you have 3 different observable conditions, a side with ripe grapes, not ripe, and a middle. And here's your number of pill bugs. So this would be number of pill bugs that you observed. So let's do this one and see, aren't they nice? Again, you can always tell that I did not write these. So they told us it'd be 99, but I'm going to count. Yes, it is. So there's 99. Oh, isn't that sweet? Because there's 3 different observable conditions, and 3 goes into 99 equally, because we are stating, because what we're going to test is that the pill bugs are found equally in each location, which means they don't care. They don't have any preference for ripe or not ripe or nothing. So we'll put 33 for expected, which is 99, and then you do the math. So let's write our null again. There is no significant difference in, what are these 3 conditions? So there's the number of pill bugs, and that's going to be what we counted, right? There's no significant difference in the number of pill bugs that are found in, I guess we could say it's not really either. And let's just put it this way, the 3 chamber conditions. And then you really should put what those are. Ripe grapes, nothing, not ripe grapes. Oh, wow. Okay. And then you do the math for those. And this was number, what, 3? Okay, move that up there. Get ready for 4. Let's set up 4. So you got 2 friends, and one says that the other one is cheating because they're flipping coins for a piece of pizza. Brandon chooses heads. It seems like that's always what happens. Brandon says that's not true. I'll flip the coin 30 times for you, and we'll see what is going on with the coin. So he flips heads 18 times. So the observable conditions would be heads, tails, as far as what that you could see. The observed would be the number of times that the coin turns this way, I guess, number of times. So head, I already forgot, was it 18? Yes. Okay, so 18 for heads and 12 for tails. And that's sweet, 30, because you got two conditions. 2 goes into 30 equally, because if the coin is not weighted, you should have the same chance of flipping a head as a tail. So there's equal probability. So we would expect the same number of heads and tails, right? So now let's write the null. There is no significant difference in what did you count. So it's the number of, I guess, times the coin lands on, and then now it's what did you observe, what are your categories. So heads or tails. So that's what we're testing. Let's see if I can get 5 on there. All right, let's do 5. I think there's 6 total. Okay, so that's simple. You're drinking different drinks. You have 120 students. They're taste testing different colas. So I'm going to go ahead and set this up here where I can write it, because we don't write ours in that direction. You've got colas, and there's A, B, C, and D. And you observe the students 20, 45, 17, and 38. Okay, so I moved the data to where my categories are vertical instead of horizontal, because that's the table that we use. And they surveyed 120 students. Oh, so sweet, because 4 goes right into 120. You so tell I did not write these. And if there's no preference, if the kids don't care, you should have had equal values for expected. So expected, I should have had 4 goes into 120, 30 times? I should have had 30 kids picking each one. So these two totals should be the same. Now, on one of the videos I made that was off by like, I don't know, small little bit. But if you round, you might get 120 here and 120.02 or something that's not exact if there's decimals. That just means that you did some rounding. So now I need to write my null, so I'm going to come up here and write it so you can see it. So the null is always going to be, there's no significant difference in what I observed and what I expected. So there is no significant difference in what did you count. These are numbers of students. In the number of, I'm going to put students. Okay, my head's in the way. In the number of students, what did they do? They selected between the types of cola. Who selected cola, because now I'm going to put, what are your categories? Cola A, B, C, or D. Okay, so now let's look at 6. 6, whoops, just kidding. I guess there's 5. Hey, look at that. I can get it all on these pages. So what I'm going to do is I'm going to stop the video, and then I'm going to work the problems. And then I think I'll load this in Edpuzzle, and you'll have to give me an answer, and I'll grade it, and we'll see how you do. Now, I'll talk to you about that in a little bit. Let me just go ahead here. I think right now I want to talk to you about degrees of freedom. Okay, all the papers fell. Let me put this here because I want to just make the point that what this means. All right, So there's 3 categories of writing utensils. So I've got the highlighter, the pen, and this, whatever this is, felt tip marker. Degrees of freedom means, if you think about it this way, it has to do with choice. Really, it has to do with, like, can you figure out something? I'll give you some examples about that. But if I ask student number 1, hey, what pen do you want to use? Oh, I'm going to use highlighter. So they had a choice, right? That was freedom to choose. The next person, you said, hey, person 2, what pen do you want? I think I'm going to use the felt tip. As soon as this person who had the freedom to choose between 2 selects this pen, there's no freedom anymore. This selection is set. So that's why you take the 1 away. So let me give you another example, and I'll do it kind of right here. So if I told you we need 5 numbers that add to, I'm going to make it up, 20. So the first number I'm going to pick is 1. Can you pick all kinds of different numbers? Do you have freedom to choose different numbers? You do. So if we pick 1 for the first number, and we have, let's say we pick 2 for the second number because I'm boring and I don't know what I'm saying, but 2. Do I still have freedom to pick the 3 numbers? I do. So this total is 3. Let's pick 5. So now we're up to 8, but I have plenty of numbers I can pick from. I could pick all kinds of things that could add to 20. So now I'm going to pick, oh, I don't know, 7. As soon as I pick 7, then that's going to give us, so that's 3, 8, 15, and I only have 1 number left that I can pick, and it has to go to 20. So there's no freedom in this box. It has to be 5. So your degrees of freedom were 1, 2, 3, 4, because you could pick the first 4 numbers, but the 5th one was known as soon as you picked all 4. So that's the reason why it's called degrees of freedom, and you only have, it's n minus, whoops, where'd that go? N minus 1 for degrees of freedom, because that last option is set. There's no choice there. All right, so let's pause these. I'll work my problems. Come back. Let's hope I get them correct. Okay. Okay, so you've put your answers in now. And let's see if we agree. I'll show you what I did. Now you just have to remember, like, my work's not terribly neat, but we'll walk through here. I think what we'll also do is we'll need to find that table to know what we're going to do with these. So let me think about that for a second. Let me pause and bring up the table. Okay, so let me bring the table up for you so you can choose what your critical values are. So you're going to use this table and choose the critical value. So I always like to think of it this way for what a critical value is. Here. So if you think about how a lot of times you have a gauge, and it looks like this. You've probably seen this in your car. Let's just do that. So RPMs. Now I'm making this up. So you've got maybe 1,000 here, and then it goes 2, 3, 4, 5, 6. And we see critical values all the time. So if you drive your car, I drove a 5-speed forever and ever, and so how far you took your RPMs up was really important. So what they would have a lot of times is, like, they would show you here, oh, that's not a very good drawing, that you were moving into the red. Like maybe right here, they would make it very obvious to you with your gauge that you were in the critical zone. And so that's what this is. So everything up to this fits your null. It means you can accept all of this amount of difference. But when you hit this spot right here, this critical value, Anything above that is not acceptable. So this would be, I'm guessing, maybe like 4,500 RPMs would be your critical value, because anything above that, you're moving into a not acceptable zone. So that's the way you can kind of think of it that way. So write your critical values, and then also write your null. So now you got two projects. You got to write your critical value. So you've already done your chi-square. That part you should have done. We haven't checked ours together yet, but you should have. Now I'm asking you, so that's the first thing you did. I'm asking you to go to the table, which I'll put it up there, and you find your critical value, and then I want you to write the null for each one. And you can do that. There is no significant difference thing. You don't have to write it all out. Okay, so let's take some time and you do that. Okay, I didn't say that right. It's not that you write your null. We did that together. What I meant to say, I got all into my drawing there, is whether you accept or reject the null based on this critical value with your chi-square. So you've already written your chi-square values in. I've asked you to do that. You just did your critical values. So now you're going to either accept or reject for each of the 5. Okay? All right, so there's the table. I'll leave it where you can keep looking at it. All right, so I'll show you what my work looks like. I didn't leave very much space. So for number 1, my chi-square was 12.8. There are 2 categories, so the degrees of freedom are 1. I need to come over here and put my p-value is 0.05, and my degrees of freedom are 1. All of this information is required to get full credit. So let's think about what that is. The first thing you have to put is your chi-square value. So we'll make a list of what we have to have. Make it over here. You have to have a chi-square value. You have to go to the table and get the critical value. In order to get the critical value, you have to know you used a p-value of 0.05. We always use that one. And in this particular case, degrees of freedom are 1. My math rule is always, what did you get for your chi-square? How does it compare to your critical value? So you want your rule. So my rule is right here. My chi-square is 12.8. I go first. My answer goes first. I'm going to write it's larger than my critical value, and then you have to decide what you're going to do with your null. So these differences are too large to accept that there's no difference. So I reject that there's no difference, which means there is a difference. So in this particular case, that would mean there's a preference for this wet side, because there is, when you write this, when you say there's no significant difference, this fails. There is a significant difference with the preference for wet. Okay, let's look at 2. I got a chi-square of 78.8, and my critical value was 11.07. So I'll come over here and write my p-value is 0.05. That won't change. My degrees of freedom are 5, because you have 6 categories, so 5. And then I write my rule. I go first. 78.8 is greater than the critical value, this reference value of 11.07. And you don't reject something hard. Like, oh my gosh, that's a huge number. I really reject it. It's like being pregnant. You either are or you're not. You either accept or you reject. Doesn't matter what these numbers are. It's either bigger or it's not. So this one says the differences are too big to be due to chance. So this is not a fair die. So I'm going to come over here and write my conclusion. Not a fair die. And over here that there is a preference, I left part of it out, for W. Okay, let's go to 3. So for 3, my chi-square is 8.42. My critical value from the table is 5.99. I'm going to write my rule. I go first. 8.42 is greater than 5.99, which means these differences are too large to say that there's, due to chance, the difference in the numbers. It's not due to chance. They're significant, so I did the math. So I reject that the number of pill bugs are the same. So particularly here, I'm going to put that there is a preference for A. And that's going to be over the middle and B. All right, so let's look at 4. Did I come over here? I didn't put it. So p-value is 0.05, degrees of freedom equals 2. Chi-square I got was 1.2. Well, I knew these looked like they were close, so that chi-square value, low. I go to the critical value, you'd have to be over 3.84, and I'm not. So I write my rule, I go first. 1.2 is less than 3.84. So I accept that these differences between everybody has 15 and you have 18 and 12 are due to chance. So there is no significant difference in the number of times the coin lands on heads or tails. So you accept the null, which means that this is a fair coin. So let's look at the last one. My chi-square was 18.57. I swear I didn't do it again. So P equals 0.05, degrees of freedom equal 1. So 18.59, and the critical value from the table is 7.82, so this exceeds that. I write my rule, I go first, so I write what I got first. My chi-square is 18.59. I compare that to the standard, which is the acceptable number, which is 7.82 or less. It's bigger, so greater than. So I reject that the COLAs are all the same. Now, sometimes there's not an obvious preference. So I don't know that I would want to write that they prefer B over everything, because it looks like they prefer B and D over A and C. I could write that. First of all, let me write my degrees of freedom are 3, and my P is 0.05. So here you could put that students prefer, what did I say, B and D over A and C. Or you could just put that there is a preference. Okay? All right. I hope that helped.